Good morning, good evening, and all the friends from all of the world. This is Digital Future Community, so it's a great honor for me. I'm Philip Yuan, and also New Leach is here, Virginia, a lot of our organizer is here to kick off this important event, 2022. So welcome all of you who are here with us today at opening event. I would like to thank you for being here for the early morning in China and evening in the States. And also we have some friends in other part of the world. So I thank you for being here with us at the very beginning of this summer festival. Firstly, I briefly introduce the Future's PhD program. I think that is the program was set up in 2018 by New Leach and me. And actually, over the past few years, we have already launched several sequence of the lecture series. I think which is an open event based on the fundamental concept of Digital Futures. So Digital Futures is a platform for the educational platform over the past 12 years and based on sequence of events, including workshops, lectures, conference, exhibitions. And PhD programs is one of the high-end lecture series of this event. And we would like to upload all the lectures, not only in YouTube, but also Bilibili. And this year we start to live stream on the Metaverse platform, Crystal Voxel as well. And instructors we select from all of the world. We're trying to join all these lecture sequences as the education open platform for all the not only PhD students, but also the graduate students and researchers, architects as well. So I would like to briefly introduce the background. In the past few years, this is at the very beginning offline event. We invited the guests, educators, instructors from all of the world coming to Shanghai from 2011 to 2019. So you can see the workshops culture makes this extremely welcome to all the students who are educated generation by generation, the new practitioners, researchers, and students. They try to understand what is the architecture intelligence and what is the potential new possibility to educate all the new young generation. You can see in 2019, we still remember because before the COVID, Mark Borey, Matthias, Andy Clark, New Leach, and Philip Block. So a lot of special guests coming to Shanghai to passing through the bridge we fabricate in 3 weeks. So that's a special memory to us, the offline event. At the same time, from last year, we also announced the fellowship who played the leading roles of Digital Futures. Every year, we're adding 1 or 2 special figures around the world who will play the leader roles and help us to make promotion and also leading the whole army going to the future. So we want to greatly show our great honor to all these special guests who be the fellowship of Digital Futures. And this year, the fellowship, we're also adding 1 to 2 fellows as well, and which will be selected by the senior members of Digital Futures. So briefly introduce, we have the workshops from June the 26th to July the 3rd. And also we'll host a special event, which is a one-day event on CDRF conference. We have around 42 lectures to introduce their papers. And Digital Future Talks will be organized by Neil during the event. And also Patrick Schumacher will give 6 lectures during the Digital Future event this year. The PhD program will starting from today. And Daniel is the first lecture, and which is part of the Tongji PhD courses. So every lecture sequence will include at least 6 lectures. And based on a lot of interesting topic, I will briefly introduce by the poster. And at last but not least is the award, which will be announced on July the 3rd of 2022, Digital Future Award. And exhibitions will be happen all around on the metaverse. We have 3 platforms doing different metaverse exhibition-based design, and looking forward all the workshops would like to present their achievements on the metaverse exhibition space. So we also will announce our new journal named Architectural Intelligence. The inaugural issue will be start June the 26th. And the inaugural surface project is from the pavilion is from Achimanga's team. So we have around 15 essays, 15 papers in the first issue. I think right now the editors are very busy editing all the papers right now. So we are looking forward to the launch event of the Architectural Intelligence. And this year, the most special of Digital Future event, not only we have more than 130 workshops around the world, but most importantly, actually, all the Digital Futures workshops will based on different languages. So we have more than 10. Right now, we have 12 languages, including English, Chinese, Spanish, Portuguese, Arabic, Turkish, Japanese, Korean, Farsi, India, etc. So that's the different language workshops, the most special factor this year. So briefly introduce the timeline, the schedule. So today is June the 13th, Chinese time, and June the 12th, American time. So it's the starting moment right now for the PhD Consortium. And Daniel will be our first lecturer to start this event. So I'd like to briefly introduce Daniel Bolojan, who is an assistant professor of AI and computational design at Florida Atlantic University School of Architecture, and a PhD candidate at near Englewood, Vienna. His current research focuses on development and application of deep learning methodology in architectural design, addressing topics of shared agency, augmentation of design process, and design creativity, and augmenting design potency. His research interests have centered on aspects of intelligence, self-organization, and creative AI, with the goal of developing autopoietic system that open new opportunities to architectural organization, articulation, and signification. Upon joining Cooper Himmelville as a computational design specialist in 2014, he started to develop a deep Himmelville neural network, the award-winning AI-based project that won both Digital Futures Award last year and an Acadia Award in 2021 as well, with the aim of augmenting design process and designers' narrative abilities. It is our great honor and pleasure to have his support and contribution to this program. So thank you, Daniel. So it's a great honor to have you. I think you are the most representative designer in the world to have this opportunity to kick off this year's event. And also we can remember last year, actually, your lectures and presentations, also you win different awards around the world. I think great congratulations to your achievements. And I think for most of the PhD students here in China, in Tongji, and I think they will have a great opportunity to learning from your methodology and your thinking, design thinking methods. And last year, actually, we have a lot interesting PhD lectures or the events, including a lot of important figures, Jenny Sabin, Sanford Quincher, and New Leach, they gave a lot of lectures. And this year we have 3 posters. The first lecture is from Daniel, and we subdivided into 3 sequences. Today, every morning time, actually the lectures, most of them from the States because it's the evening time on the other side of the planet. And the afternoon session actually most of them from Europe, from UK and from Europe. And at the same time, Patrick Schumacher will give 6 lectures during the workshop time. I think that is a brief introduction of his theory. So tonight, also, I would like to invite you to participate to Mette Thompson, who is from CETA, Royal Academy of Fine Arts, Denmark, who will give a lecture on the computational strategy for bio-based materials. So today, let's welcome Daniel Bolojan, whose topic today will be creative AI in architecture, how AI is shaping the future of design. Let's welcome Daniel. So we'll give the floor to you. Thank you.
Thank you, Philip. Thank you for the introduction. It's really great to be here. So today I'm just going to share with you some of my latest work and also some work from the past so that in a way you can understand the context. Let me know if you're able to see the screen. Are you able to see the screen?
Yes,
the main screen or the presenter?
The main screen.
Okay, perfect. All right. So once again, thank you for the invitation. It's really great to be here. So what I'm going to talk about today, or I'm going to try to give a different perspective to the research that I've been engaging in for the past almost like 5 years now, 4 or 5 years. So mainly my interest, my research interest, like was described by Philip as well. Early on, when I was still studying at Studio AD in Vienna, my understanding of architecture was quite challenged by, or highly influenced by, system theory, Christopher Alexander. So over those years, I started, or my interest spanned like a variety of areas, such as complex systems, agent-based systems as a generative model, agent-based systems as agent-based live process simulations. And this is something that research that I did together with Patrick and another team of researchers in Vienna. And then since 2016, I started to be mainly focused on creative AIs. So for me, it's important in a way to introduce this because you will see that there is a lot of there are a lot of ideas from this kind of complex systems brought into this research, to the AI research. One of the recurring themes, or 2 of the recurring themes in this research are this kind of idea or concept of encoding intelligence and the articulation of design processes in which design intentions and architectural intelligence are embedded within emergent processes. And the second one, theme, is creative AI, which explores the potential of teaching machines to interpret, perceive, and to be creative. So these are some main questions that maybe I'll try to somehow see if we can answer them today. Can AI-driven processes augment creative agency? And can AI be used to expand the design's search space beyond designers' accepted boundaries? So to address these questions, I will try to provide a base for what I mean by creative AIs, creativity, and also design. Yeah? And most of the examples are, in a way, almost like bits and parts of a bigger idea. Like I'm really trying to understand which are the component parts of a creative machine, for example. Yeah? So in recent years, there has been a surge in research when it comes to design techniques, experimentation, addressing the issue of creativity and artificial intelligence. Because of this rapid speed or pace of advancement in the field of AI, new examples of machines being able to compose, to paint a painting, write poems, design everyday objects emerge regularly. Yeah? What has changed in recent years to cause this kind of widespread disruption is the sheer amount of data that is gathered on a daily basis, yeah? And also the speed of computers that are able to process that data and to uncover insights. So one question here will be, how do we evaluate if something is creative or not? Because if we are looking at these two examples playing on the screen, we might interpret the outcomes as being creative, because there is a level of novelty involved as well as a level of novelty appreciation. According to Alan Garnett, this is significant because if something is too novel, we cannot appreciate it. And if it's too unexpected and too unrelated, we cannot appreciate it as well. So if it's too similar to what we know, we still don't appreciate it. Yeah? But there is this sweet spot where ideas that we appreciate are creative, have a blend of familiarity and novelty. So all ideas in the end, they have this kind of cycle. They reach a point of overexposure, of saturation, where they become cliché and they start to lose popularity and downfall until they grow out of date. Yeah. So here, I think we have to make a clear distinction, or there is a significant distinction between this view of creativity that resides solely in the artifact and it's assessed by society. So it's a societal, in a way, kind of assessment of something. And the other view where some processes have the capacity to generate artifacts that are deemed creative. So my research explores the potential of teaching machines to interpret perceived to be creative. Thus, I'm more intrigued by the second perspective. Understanding how a social evaluation of an artifact determines whether or not is it creative might aid in the creation of a process that produces creative outcomes. So very often we are kind of stuck with these kind of ideas of trying to compare machines with humans and asking these kind of questions of, is it possible for a machine to see the same way that a human does? Is a machine able to be creative as a human is? And for me, those questions are quite irrelevant. And in the words of Alan Turing, he was asking this question, can a machine perform something that can be described as seeing, but is very different from how humans see? And he's also giving this interesting perspective that we do not wish to penalize the machine for its inability to shine in beauty competitions, nor to penalize a man for losing in a race against an airplane. So in his papers in 1950s, 48, he started to introduce different models of machines that have a certain degree of intelligence, and that those kind of machines are still present today. We are still basing, in a way, most of our models that we are working with today, they are based on these main ideas developed by Alan Turing. So some of these models include logical computing machines, unorganized machines, and modifiable and self-modifying machines. So the first one, logical computing machines, you'll see they are very typical expert system types, while the unorganized machines and the modifiable self-modifying machines are mostly learning systems. So these are models that are at the core of what we define today as expert versus learning systems. So this shift from expert system to learning system is one of the most significant shifts we are witnessing today. And this is quite evident in computer science, in architecture, lately in arts, in healthcare, transportation, and so on, and many, many other fields. Expert systems were very popular in the 70s and 80s, while learning systems, they became very popular around 2006 when Jan LeCun created the CNNs, convolutional neural networks. Which are the implications for architectural design? So these are some questions that I'm always wondering when it comes to these new technologies. So if we want to analyze in a way what an expert system is, an expert system is a knowledge-based system. And these kind of knowledge-based systems are based on logic systems, which feature hard-coded solutions. And they require a sort of human expert to input information into the knowledge base. Learning systems, which are systems based on neural networks, they rather than relying on hard-coded solutions, they learn from example, or they learn by example. They learn solutions from first principle. So we can say that because of these differences, expert systems are unable to generalize, and they are limited to pre-programmed solutions, making them unable to solve solutions or unforeseen conditions. Sorry. Therefore, they might be great. We can use them perhaps to solve sequential problems with finite steps. On the other hand, learning systems can generalize and offer solutions for new conditions. They are most effective when you want to find insights that you may not even know about, when you have a significant amount of uncertainty in your problem. So here, just to give you an idea of examples of learning systems. These are a few examples of GANs, generative adversarial networks, variational autoencoders, flow-based models, and diffusion models. There are many, many other models out there, but I'm showing these models here because these are some models that I'm also engaging with in my research. So this question, I'm always trying to go over it in all my presentations, because as designers utilizing or using this kind of AIs, we are kind of confident that we are moving away from this kind of idea of rule-based design, expert system kind of computational tools. We use this kind of GAN architecture or any kind of type of architecture with thousands and thousands of architectural examples, and these deep architecture are able to learn the representation of the data that we present them with. And for me, always the question is whether or not our model is generalizing well, and what is happening if your model is not generalizing? What if your model is overfitting? And what I mean by overfitting here is almost like it's memorizing the knowledge instead of learning the principle of the knowledge. So if your model overfits, pretty much you can say you almost have a sort of like expert system. You don't really have a learning system. Some designers might argue, that when working on creative tasks, the issue of overfitting or underfitting is of little concern, because there's value in the artifacts produced by poorly trained networks. For me, always that's a great, in a way, discussion. But for me, it's always a question, why do I need this kind of network if I can create easily that kind of novelty out of something that doesn't even learn? So for me, it's always, I'm asking, how is that different from a Blender? You just input thousands of images in, you spin it up, and you get interesting results, strange results. And for me, having this analogy of a machine that overfits is not more creative or intelligent than a Blender that simply spins up what you put in without learning any relationships between the elements you put in. I really like this quote from Bolojan that, in a way, illustrates clearly the problem, in a way, with underfitting or overfitting networks. Science is built up of facts as a house is built of stone. But an accumulation of facts is no more a science than a heap of stones is a house. So I think in order to be of any use in the design process, a network must demonstrate that it was able to understand the correlations between different features offered or presented in the input data set. In other words, a network has to demonstrate the ability to generalize. And why I say that is because here there is a clear, nice illustration from John Giro, where this will be, in a way, the difference between generalizing versus just memorizing. So you have on the top part, you have the specific problem. And if you were just to learn, memorize, in a way, the solution to that problem, probably you're not going to invent any new way of solving that problem. So here we see that we have different kind of levels of there is a specific problem, there is a specific solution to that problem. And based on that knowledge, then you develop a sort of general understanding that problem versus the solution relation between the two. And that leads you then to come up with new novel ways of applying that principle to completely new scenarios. Yeah. So in this case, we see that this kind of idea of you have an object that requires motion and you have a force, you have an applied force that can be translated also into a shopping cart now. Yeah. So that kind of knowledge was generalized and applied to a different domain. Yeah. So I think this is the interesting part also, or where we have to aim to be with AI as well. Yeah? We don't want to just memorize things. We actually want to use AI to help us come up with new, interesting solutions to certain problems. So although AI can, in a way, exhibit a sort of form of intelligence and a form of creativity, it should not be equated with or confused with human creativity or intelligence. In terms of human creativity, if we think about ancient cultures, they lack this kind of they lacked our understanding or current understanding of creativity. They consider creativity as something, as a form of discovery. And then in the 18th century, they start to use, in a way, or the term creativity starts to be very much associated with the idea of imagination. And in the 19th century, theories such as Bolojan began to reflect on and published his research on creative processes, pioneering the scientific study of creativity. Although this scientific study of creativity produced many theories, models, and systems throughout the 20th century, defining creativity in objective terms was and still remains, I'll say, challenging. If we are looking at Mark and Bolojan, so Mark and Bolojan work is mostly focusing on understanding the limitations of the machine creativity, described as machine creativity. In a way, it's described as the context in which the computer at least appears to be creative to some degree. Through this task, Bolojan believed that computational ideas can help us understand how human creativity is possible. So in that, through that research, he identified three types: combinational, exploratory, and transformational. And when we talk about combinational, is this kind of idea, a form of creativity that produces unfamiliar combinations of familiar ideas. Exploratory creativity rests on some culturally accepted style of thinking, and mostly you are exploring within that kind of defined or style kind of space. But in the case of transformational creativity, the space or style itself is transformed by altering or dropping one or more of the defining dimensions. So in this way, you can start to generate ideas outside of those kind of design spaces. When it comes to machine creativity, I think Demis Hassabis has a definition of three types of creativity as interpolative, extrapolative, and inventive. So the way that he's describing this is that in the case of machines, if you have a data set and the machine is engaging in a sort of interpolative kind of creativity, then mostly what's happening there, you have an averaging of the samples in your data set. Yeah? And by averaging, the average sample will be a new sample. Yeah, it's something completely new, but it's still confined to the initial data set. Yeah? Well, extrapolation is something that tries to get outside of that data set, almost like if you think about playing a game, it's almost like extrapolation would be the machine is able to create new rules in a way. In that invention, it's almost like to say that the machine is able to invent a new game. Right now, currently, we have a lot of machines that are very good at interpolation. We have a few machines that are quite good at extrapolation, although it's quite limited form of extrapolation. But we have no machines for sure that are good at invention. Other things that are missing in machine creativity are also concepts like, or ideas like concepts, abstractions, abstract thinking, analogies, memory systems, or imagination. So we hear a lot about this kind of idea of artistic creativity, but think about creativity in other domains, such as scientific creativity, which produces beautiful new theories in mathematics or physics. So once you get into these formal domains, I'm not sure how much of what we call today creativity is nothing more than a form of meaningful random search and basically structuring how we search for the right things. Yeah, and the two main components here will be for sure the idea of synthesis, how you synthesize, and then how you search. Yeah, and we can say that certain people, they have this ability to shape the direction in which they are looking for new things. When you talk to digital composers, you'll notice that they start with some random music strings, and then from there they start to manipulate that string, enhance it, in a way almost like they are shaping and expanding in a way the possibilities. So can AI augment how we conduct meaningful random searches and design explorations? Can AI, in that sense, then, can AI kind of understand certain design intentionality? According to Costas, what AI establishes above all else is that every possible form is already out there, and it's simply it's simply a matter of searching for it. While Neil Lynch describes it as it's merely a question of conducting the right search. It's not about the designer inventing some new proposal by drawing upon his or her genius, but rather of selecting the best solutions from a range of existing possible options. So for me, it's always, I'm wondering this question, what is the point of engaging with these kind of very, very sophisticated learning machines when the results are ultimately evaluated by a human agent? All outcomes will be constrained by our own limitations because we are very frequently unaware that we are trapped in this kind of design local minima. Yeah? Very often we have the impression that we are very creative, but actually we are really operating at the local minima kind of level. Yeah? So without a doubt, this the human agent plays an extremely important role in the process. But what we consider to be creative is frequently something that is quite conventional, because we have a very structured way of seeing the world around us, and that limits the way we evaluate certain things. So people evaluate in that sense outputs based on what they already know and are familiar with. And when confronted with what they are unfamiliar with, they may believe that those things are new, but what is new? Is it brand new for some, but not for others? So can AI augment and help us to expand our design space beyond our accepted boundaries? So if we, to now we covered just briefly like these kind of ideas of intelligence, creativity in a more abstract, or not abstract, but in creative industries. When it comes to design architecture, mostly what we refer to creativity, I think we are talking about design mostly. But design, I would like to describe design mostly as a creative problem solving. Yeah? There is no doubt that creative problem solving is a complex behavior, and the act of designing itself is one of the most complex human intelligent behaviors. As design, it's this kind of multimodal enabler where different tasks can be addressed at various degrees of abstraction through different mediums such as text, drawing, painting, 3D models, and it requires this kind of problem-solving abilities or creative problem-solving abilities. So we can describe in that sense the process of design as a navigation through one initial task the task of specifying the design problem, and then the final task, the proposed solution. Yeah? So it's sort of navigation, the entire design process in the end. So this traditional, in a way, notion of you're starting from an empty piece of paper, in my opinion, actually, what we are dealing with in design is this kind of flock of birds that constantly moves and constantly changes. I'm taking certain design decisions, and suddenly my design space either expands or contracts. And that kind of process, in a way, is something that happens constantly while I'm engaging in the process of designing. This is one example, very early example of trying to address this kind of question of how how can a designer explore the design of the design space of possibilities, so that it's able then to see which are all the other options out there. So in this instance, you're mostly defining a few examples that describe your intentionality, the kind of designs, the kind of intensities, the kind of bundling that you're interested in, and then you present that kind of design in a way to a machine. The machine tries to analyze, tries to understand it, and then it tries to create for you a sort of design space. And that kind of design space is very interesting that we can easily analyze it towards multiple kind of parameters that might have an impact on design or might describe design intentions. So in the end, it's almost like a process of, once the machine creates for you this kind of design space, it's almost a matter of exploring things. Yeah? And in some senses, it might feel almost like a sort of automation kind of process, but just think about it as a sort of augmentation in the sense of once you have the design space generated, now it's much easier for you to take riskier design decisions and to get maybe to the fringe edges of your design space. Yeah? And those options mostly you'll not explore in a conventional way, just because it's time expensive in a way to explore those kind of ideas. And then you have that kind of not preconceived, but a sort of behavioral, a sort of way of designing that is going to guide you towards design decisions and those design outcomes that you're mostly familiar with. Yeah, so you're not going to risk in a way these kind of fringe ideas because it's too expensive time-wise and also other aspects. So in this instance, even if the space is even if we talk about the sort of automation, because you have a machine that looks at your designs and then starts to spew in a way or generate designs. Now you're able to explore those options that normally you'll never explore, yeah? Because they are too expensive to explore. Other questions here for me are important, especially when it comes also to this angle of designing creativity. How do you design a design process that leads to creative outcomes in a way? And this aspect of how we are interacting then with the tools, which are the rules of interactions, which are the objectives. These are some topics that I'm quite interested in. So we have this notorious painting, a horse head, a clock, the picture, and a suitcase with text that undermines in a way the image depicted. Yeah? And Magritte's The Key to Dream signal this kind of widening rift, art and language, this kind of rift between art and language. And he was focusing on this kind of surrealist creed, which was full-throated grab at meaning and language itself. So seeing becomes before words. The child looks and recognizes before it can speak. But there is also another sense in which seeing comes before words. Is it seeing which establishes our place in the surrounding world? We explain the world with words, but words can never undo the fact that we are surrounded by it. The relation between what we see and what we know is never settled. And as social agents, we are constantly interacting with the world around us. So what if we we have machines that could interact with humans and learn from one another. So this kind of idea that for me, it's interesting to explore in the context where soon we are going to have, and even these days, we have a lot of AI agents around us that we interact with daily without even being aware actually that we are interacting with an AI. And we have this kind of process of that AI is getting better to give, in a way, the kind of solutions that we are looking for on a daily basis. And also we as humans, we start to, in a way, augment and start to think differently perhaps about certain things. So which are the goals of interactions? So which are the goals that we are optimizing towards? Which are the, is the optimization in the end the correct goal? Is the optimization enough? And these are questions that for me, I'm always trying to think about, which is the optimization goal for art, for example, which is the optimization goal for qualitative criteria. In this sense also, if we're talking about design, which is the optimization goal for design, as design is not necessarily an optimization towards a goal, but mostly it's a sort of negotiation of multiple processes, multiple tasks, design tasks in a way. So although current models, they demonstrated this ability to engage and outperform humans in tasks that can be broken down into measurable goals, large parts of life is not about winning. Yeah? It's about adaptation, negotiation, and not just winning a game. So for example, just to briefly explain like how a neural network works, if we want to train a neural network to look at samples or images, satellite images, and translate them into map view, we can simply train something called an autoencoder, which is a sort of neural network to translate this image and then compare the real pair. So what will happen here is the autoencoder will use some convolution blocks, downsampling the images a few times, then upsample a few times to return to the initial image size. In the end, the reason for this kind of downsampling and upsampling is to compress features which might be far apart spatially, but are related in the image. So other networks that mostly I'm going to also show today are these GANs, generative adversarial networks, which are adversarial training. They engage in an adversarial kind of process when they are training. Then we have variational autoencoders, maximize variational lower bounds, flow-based models, and diffusion models. And for me, it's always important. Also, CLIP, it's another network that I'm going to you're going to see throughout the examples that I'm going to show the projects and diffusion models. So for those of you that don't know what a diffusion model is, because this is quite new, diffusion models are quite new. It's diffusion model. It's a generative model, as is the variational autoencoder, again, flow-based models. So they are all from the category called generative models. So it's a generative model, and the central idea of a diffusion model is that if we can build a learning model that can learn the semantic decay of information due to noise, we should be able to reverse the process and thus recover the information from noise. Yeah. So this concept is quite similar to variational autoencoders in that it attempts to optimize a loss function by projecting the data onto the latent space and then recover it to its initial state. Yeah? But in the case of diffusion models, instead of learning the representation, the system aims to model a series of noise distributions. So one of the challenges with this kind of AI models is that they are domain specific. And when used in architectural design or in a design process as discrete systems to address multiple architectural systems or tasks, they tend to flatten relations between architectural systems. And this is rather problematic as the outcome of architecture process is codependent in a way on multiple interrelated systems. And in the end, we want AI models to be aware of the variety of correlationships between architectural systems. So when it comes to this kind of idea of interacting human agents and AI agents, the importance of a sound process with non-exclusionary human workflows has been previously advocated by Garry Kasparov, former world chess champion. And according to Kasparov, the limitations of current AI workflows can be assisted by calibrating the relation between the human and artificial element in the process. And in this sense, he observed that a weak human player plus a machine plus a better process is superior to a very powerful machine alone, and more surprisingly superior to a strong human player plus machine and an inferior process. And the goal here then is that of creativity and intelligence amplification, to use these kind of technologies as a tool to enhance human decision instead of replacing humans with autonomous AI systems. So I'm going to show here one research paper that I wrote together with two of my colleagues here at Florida Atlantic, Manus Merviso and Shimin Yusuf. And in this paper, we were looking at how interconnected AI-assisted workflows can address limitations of current language models and streamline, in a way, machine vision-related design tasks. So what we were interested here in is how interconnected AI-assisted workflows can address the limitation of current language models and streamline, again, machine vision tasks for architectural design. So AI models that focus on language and vision have advanced exponentially. And as you can see here, we are talking about a span of about something like 3 years maximum. And we have recent networks like Leap, DALI, Encoding, diffusion models, and so on. Unlike other types of generative adversarial networks, which require large data sets for training to produce good results, there are natural language models are pre-trained, or most of them are pre-trained on massive data sets with millions of data samples, and thus can produce results quite easy and quite quickly. So what we were looking at here, we were looking at which are the limitations and identifying the way opportunities for integrating these kind of natural language models into broader AI-supported workflows, including interaction with networks like StyleGANs, with CycleGANs, with StyleGAN data, diffusion models, and so on. So this research stems from this acknowledgement that a high level of complexity in the act of design it stems from this kind of idea of the high level of complexity in the act of design, which, like I mentioned before, design can be understood as one of the most sophisticated aspects of human intelligence. As design is this kind of multimodal endeavor where different tasks can be addressed at various levels of design through different kind of mediums like text, image, 3D, and so on. Direct application of AI models where one model tackles the overall design complexity is kind of problematic. And textual encoding of design concepts only allows a reductionist in my understanding of spatial complexity, since the outcome of architectural process is codependent on multiple interrelated systems. So the first case study here in this research, we were looking at this very reductionist approach where the workflow involves discrete neural language models, which rely on text prompts alone or text prompts and image references. So here we have a few prompts, two prompts that we were exploring, and try to see how to engineer in a way the prompt in order to get certain quality results. Yeah? But this is still quite limited in terms of agency. As a designer, you mostly just have access to this aspect of just defining the text and not much. Yeah? And if we look at the results are quite poorly represented. In the next case study, we start to propose a process that was more curated, where we start to introduce different combinations between multiple networks. And the intent here was to span longer, semantic distances, thereby, in a way, increasing a sort of a chance for creative solutions. So in this instance, we started first with 3 models, a diffusion model with Vikigan and with DALI Mini. And as you can see here, like the way that we were seeing a branching composition in Milan or urban fabric, the kind of results are quite poor in a way, as the branching composition mostly refers to a sort of low-level composition when we refer to that, and the network, it's kind of interpreting it as just a sort of like interstate that is kind of branching as a big street or circulation node. So here what we are proposing, that we are saying there are certain ideas that can be described through text much easily and can be captured much easily through text, and other ideas that can be much easier described through image, for example. Yeah? So in this case, we have, for example, a stalgan that is trained with images of mountains to create this kind of idea of branching. And then from there, that kind of output from a stalgan aids the source for the language model that tries to create that branching composition. So in that sense, you see, it's almost like there are certain concepts that can be described better through image, and others that are better described to text. And when you combine these two together, the result actually is much better. Yeah? So the next one that I'm going to show is the same kind of idea. It's just there are more other models here. So there's a diffusion model, there is a Midas network, there is a latent diffusion, there's a PyTorch 3D, there's a guided diffusion model, there's a clip model. So there are multiple AI models that they address different tasks in a way and combine them together, and then allow them to generate designs in that kind of way. So this is something that I'm currently working on, and the network can be trained better, and I'm really working on that to have a better trained network. So here, these are some of the results of these kind of diffusion models, where you have multiple kind of networks, some that address with depth of things, others that address the text representation, the semantics, others just a visual representation of things. And these are some of those results. So in this case, there are certain prompts like text prompts introduced without any kind of image reference, where the network tries in a way to understand the description of the text and then translate that into image that corresponds in a way with a text description. And some very rough in a way results of that. So prompt engineering, it's becoming then something extremely important when working with these kind of neural networks. And certain networks allow you to have this, other networks not really. So prompt engineering, what it does, it allows you in a way to emphasize and de-emphasize certain aspects. So in this case, you see as a prompt, there is an idea of a beautiful main entrance interior, warm morning light, concrete floor, curvilinear design. So in this case, right now, you see the fact that I start to specify a concrete as a material, it kind of started to create all over a sort of feel of concrete. Yeah. But then later, through prompt engineering, you can easily start to assign different weights to certain words and kind of say which word is more important than the other one. So in this case, I was saying I want to have some walls that maybe they have aluminum panels and other walls that have wood panels. Yeah. So in this case, I just assign the same kind of weight to both aluminum walls versus wood walls. Yeah. And as you can see, the result is you end up with something that might look like a wood wall, but in the end, it's not really. It's a sort of mixture between the two. Yeah. Then here, where you have this relationship switch, you have aluminum in a way overpowering wood walls. You start to see and have this kind of sense of more aluminum kind of texture. And here, the opposite way, where you have wood wall as a higher weight, yeah, and you have that coming through, yeah. So that kind of prompt engineering, it's quite interesting, but at the same time, it offers you a very limited level of agency or degree of agency. As you, as a designer, you mostly just have the only way to control or to influence the results is through text. Yeah? So other ways is really to use a sort of map that helps guide the entire process, plus engineering in a way the prompts. And while doing that, in this case, you see you have a beautiful lobby interior, has a weight of 4, with a front desk, which is a weight of 2. And that's why in some of these images, you don't really see a front desk and morning light, curvilinear design. Yeah? The result, as you can see, it starts to be more interesting and much cleaner once you start to also input this kind of extra level of information, which is just a map. And this kind of process, then you can easily, as a designer, you can start to interact very easily with this kind of network. Yeah? You can easily just sketch a sort of main composition of something, and then that's a sort of starting base of the network. And you can give that certain text description to specify exactly what kind of qualities that space should have. So one problem here that I have when it comes to language models is that does the network actually really understand does the network really understand the kind of description, the kind of meaning of the image versus the text? Yeah? Because my assumption here would be similar with the case of a cyclogram. So in the case of a cyclogram, you have a process where you want to translate from an image, let's say a satellite image, to a map image, and then the network, in order to prove that it's able to learn that, it should be able to prove that it learned actually how to translate and the correct relation between the two. It has to translate back from a map image to a satellite image. Yeah. So in that way, it's almost like to say the network has to prove that if you translate from English to German, when you translate from German back to English, you should end up with the same meaning, the same sentence. Yeah. Because otherwise, if not, that means something got lost there in translation. Yeah. And in the case of language models, so right now, this is one question that I have, and I'm still researching on this topic to see, is this really a problem? But currently, the research that I conducted on this is that there is a difference. I'm using the same network to encode or to describe the text versus to read the image, and the results are quite different. So we are using this kind of image, this kind of prompt, a beautiful lobby interior with a front desk or morning light, curvilinear design. That's the input as a prompt to generate the result that we see in the middle. When we ask the same network, the same click network, to read the image and to describe it, to caption, the result is a bit different, a view of a lobby of a building with sculptural ceiling. So it was able to pick on the fact that it's a lobby, and it's just picking on this kind of sculptural ceiling aspect. But there is a distance, there's quite a distance between the first prompt versus the result, the image, and versus what the network actually reads in the image, as you can see here. So the next project that I'm going to show is the Gaudi neural network project. And the problem here, the architecture problem that I'm trying to address is I'm looking how these kind of networks can identify relevant compositional features in the samples of Gaudi and other samples from nature or on any kind of domain. The reason for that is what I'm looking at is that there are meaningful tectonics here that are defined by Sagrada Familia that are constrained to this very symmetrical kind of composition. And the goal here was to try to deploy this kind of deep learning strategies to liberate somehow this intricacy, this composition, this intricacy of the tectonic detail, and then perhaps apply it on more complex compositions. So in the end, these developed strategies, they enable this kind of intricate tectonic detail to be play out on more complex geometries and compositions, as you can see here. So when it comes to the training, we have to look at almost like the generation of training data. We can look at it almost as it's a process in which we as humans, we transfer the knowledge and the reasoning living inside our brains into the machine. And the machine that is merely can be understood as merely an empty shell somehow without the training data. So, but here another problem is that similar with parametric design, where you have this kind of design possibilities which are predefined a priori, relying only on data sets, as in this case, it's going to lead to a sort of form of interpolative kind of creativity, which is very similar with what Grasshopper or parametric tools does. So the constraints are already set, and mostly create variations within those constraints. So the same, relying only when it comes to one agency of design, relying only on data sets leads to a very very constrained in a way output in the end. And here, that for me, like I started to look at how can I move outside in a way this kind of constrained space or this kind of mode of interpolation only. And in the end, my goal here was not to replicate Sagrada Familia. My goal here was to look at the example of Sagrada Familia, have the network learn properly the example, and then that apply that network on new scenario and propose new solutions. That's what the goal. That was the goal here. And in order to move out or move away from that interpretive mode, I started to apply about something like 3 strategies. One that was addressing the perception of the machine and designing the way that the machine sees and reads features, and which are the architectural relevant features. Second strategy was this kind of idea of progressive training, where you start to train at a certain level resolution, 1 by 1, like 4 by 4, 10 by 16 by 16, 32, 32, and so on. And the reason for that is that at different levels, different resolution levels, you have different kind of information encoded. If you want the network to learn the composition, only the composition, overall composition of something, that composition probably you can find it at 32 by 32. If you want the network to learn high-level features like details as ornaments, then you might want to have a network that trains at the level of 512, let's say. So in this sense, the progressive training is adopted here in order to be able to learn correctly all those representations at different scales and be able then to disentangle them in a better way. And another strategy, the third strategy, was to develop a node-based system. For some reason, this video is not starting. Okay. A third strategy was this kind of idea of developing a node-based system of 6 interconnected networks that would provide additional access to compositional scales. So with these kind of mechanisms and methodologies, you start to be you're able now to encode intentionality, design intention, and intelligence at multiple levels of design. So in this case, there are 6 networks, and interpolative abilities are featured by network 1 and 2 and 3 and 5, while limited extrapolative abilities are featured by network 4 and 5. Yeah? And in the end, what's happening is that network 1 is learning the representation of low-level composition features, while network 2 performs text-based queries to enable a more strategic search of the low-level latent space and provide mechanisms for encoding design intentions. Then network 3 is mostly the network that learns the representations of the non-architectural domain from which high-level features will be transferred, while network 5 is learning the representation of the architectural domain. And in this case, that's Sagrada Familia. And in the end, the latent space of the 2 networks, network 3 and 5, they serve as an input data set for network 6, which is responsible then for the transfer across domains represented by network 3 and 5. So certain aspects of 3D, I start to address those aspects, and there is one network that I developed, style-based or style-based network, 3D network, that's able to look at 3D meshes and learn the representation of those meshes. Unfortunately, there is something with the videos in the presentation. These are supposed to be videos. So another example that I'll show you here is another project called Agent-Based Creative AI, which consists, or the methodology of this project consists of a holistic approach to design processes, in which a variety of interconnected networks, which are coupled with agent-based systems, are deployed and address different architectural and design tasks. And this methodology kind of develops on this kind of idea of system theory, Christopher Alexander, where architecture is understood as a system comprised of and working with a series of interrelated systems. And here for me, it's always the question, like I mentioned at the beginning of the lecture. For me, I'm always looking at which are the components parts of a machine, of a creative machine. Which are the kind of interactions that should exist between certain parts of that machine for the outputs of that machine to be created. So in this case, multiple discrete neural networks nodes are developed in this process to explore ideas of exploration of how you qualify design and then how you generate design. And this exploration enabled this kind of like classification strategies, language-based queries, language-based generation strategies, sorting, filtering, searching, and design explorations of a variety of design-related tasks. Yeah? And in this process, we start to develop also like tools for topology optimization, for structure wizards, in a way to start to encode structural heuristics in agent-based systems, and in this way to have a real-time kind of model that is able to give us that kind of feedback. My apology, for some reason the video is not running. I will just go over. So here you can see some this large diagram, they describe in a way the design process, broken down into two parts. Certain aspects address very global aspects of design, other very local, other like more functional, more pragmatic, and so on. And here we also start to develop ways of qualifying the results, because as in the case with parametric design, we were promised in a way this kind of way of working in which you can create thousands and thousands and thousands of variations. But one big problem with that is how do you evaluate those variations? How do you decide which one is better than the other one? So here we developed this kind of machine vision kind of algorithm that it's able to look at outcomes and start to give in a way certain qualifying values. So we start to also look at aspects of, there are certain parts of design perhaps that can be addressed at a 2D level and at a more conceptual level, or other parts of design have to be addressed at 3D level. So in this case, we start to apply the same 3D style-based network that it's able to look at these 3D meshes and start to create interpolations and variations of this. And here we have the same kind of algorithm now applied on 3D meshes, like to try to evaluate against 10 criteria, like qualifying criteria. Okay, and the last project that I'm going to show is the Diffusion Model project. The Diffusion Model project is a project that now runs for at least 3-4 years. And it's an ongoing project. There are certain things that sometimes I can show, sometimes I cannot show. The sense of certain things are still in development. But Diffusion Model as a project is a result of a cumulative effort undertaken by Diffusion Model, which works at the intersection of practice, architecture, deep learning, AI neural networks. So the main team of the Diffusion Model project currently is composed by Wolf, Briggs, Caroline, myself, and Efilena. So one problem with Diffusion Model repertoire is that it's not a problem, but one characteristic of Diffusion Model repertoire is that it's not very homogeneous, it's very complex as a style. So because of that reason, certain things are quite complex in a way to evaluate. I'm going to go over that just in a second. There are 3 main topics that are addressed here, and there are 3 main categories. So we are looking at Gestalt, like relation, form, and function and form. And in those aspects, there are certain tasks that are meant for automation, other tasks that are meant for augmentation. And then we have organizational, which is, again, automation, augmentation, and technical, which is automation and augmentation as well. So again, the kind of data set and the kind of repertoire is quite complex. So for us, the way that we started, this started mostly as a way to augment design processes, and then it started to spread through many other like aspects of design. So we are looking at organizational aspects, as in creating functional models and to be able to create an organizational model of a building and have an AI in a way assisting with that. Then other aspects which are mostly in the technical side of things is the aspect of environmental. We have a lot of types of environmental tools that we use through Diffusion Model that give you real-time evaluations. And then also aspect of more technical aspects as creating families of panels from this kind of buildings that are quite complex, have complex facades. And my apologies again, I don't know what's going on with my videos, why they're not playing. Perhaps I'm going to stop sharing just a second and share it again. And we are looking then at multiple aspects of where we can bring this in the design process. Can we bring it very early on? Can we bypass in a way the step of building a physical model and then digitize the physical model and then run simulations? Can we simply just have the simulations the very first step? No. So right now I'm sharing the wrong screen probably. Okay. So one important problem here is that this is the data set, the initial data set. This was the initial data set before augmentation of the Kupion-Blau buildings. Yeah. So what you can see here is that you have certain buildings that are overrepresented and other buildings that are underrepresented. And this is a big problem because that's going to create a very big bias in the data set. Yeah. The data set and not in the data set, very big bias in the model output. So if we have certain projects that were built, probably they have more, they're more documented than if we have projects that were not built. So in that sense, we have to develop certain algorithms that are able to look at our data sets and learn features and then augment based on features the data set, yeah? And try a way to balance those kind of features. And the way that the Diffusion network it's working and it's trained on in a multimodal way, in the sense of we have multiple types of data sets that are used to train the network, not only images, we have also, or not only one type of image, we have depth maps and material IDs and then renders and so on, or sketches, text, 3D. Some results early on in 2019 of some of the first credible results, I'll say, from the Diffusion network, where we start to see more and more the potential of what the network can do. And these are some examples of the network being able to interpolate and walk in a way through the latent space in an algorithmic way. So all these, in a way, results were quite fascinating, and also in the office, people were very fascinated. But one of the big problems is that all these explorations are algorithmic in the sense of there is a sort of code that is written to be able to explore this latent space of the network. Yeah? And that creates a very heavy or very high barrier for the designers in the office to engage with that tool. So what we started to do, we started to think of this aspect of how can we make it more friendly, more user-friendly for our designers to engage with the network. So we have here a few strategies, and some of them are like Latent Space Explorer, Latent Space Explorations, projections, and space queries. And in this case, for example, this cloud is constantly being updated and constantly new results are outputted or placed into this cloud. And then designers, they can easily, through a browser interface, they can interact with this cloud of design options. And slowly they start to, in a way, intuitively understand like the types of buildings, how they are positioned next to each other, what types you have in this lower part versus the other part, based on this kind of clustering. And the same you see here. We have the same also for sections, for floor plans. So in this way, it's quite easy for designers to interact with a model. And the same applies also in the case of the 3D nodes of the Diffusion network, where designers can easily interact with the latent space, the 3D latent space of the node-based network. So other exploration here is this kind of idea of setting certain like proximity values. Like we have an initial design that was picked from the the entire QPML universe or DPML universe. And then from there, that design can be in a way input and search for variations or close neighbors of those options. Yeah. So what you're seeing in the upper corner, you have mostly very, very similar variations. And then on the lower corner, you have very far away, in a way, variations. But still, there's an underlying, in a way, idea that is there describing both. And in this case, also we have this kind of way of exploring the space, like gradually searching for the next neighbor, next neighbor, next neighbor, next neighbor, and walking away, sort of very smooth away through the space. So all of those are quite more friendly than purely engaging algorithmically with the network. We also start to look at this aspect of how can we bring perhaps text query into the network. Can we type in a specific phrase, a specific type of building that we are looking for? And can we have a network look through this cloud of samples and extract, based on the text query, extract the samples that have the features described in the text. Yeah? So for example, an open public space with an overhanging roof. This is not necessarily like tagging, like in the case of Google. It's really like looking at all the images in the cloud and try to find the similarity between the text and the semantics of the image. And the closer those are, the higher that's going to show up. Yeah? So in this case, you see we have the irregular shaped office tower. So we have value of 0.29 when it comes to cosine similarity between the text and the image. And in this way, then the designers can easily just type in a text that describes, in a way, the kind of design that they are searching for. And then from there, they can easily just extract. Yeah? And we have also very like a more engineering, in a way, kind of prompt engineering idea, where you have a very specific structure that you can use to query for things. So you can start with the type, the first words are the type, comma, and then you have material, or you have other kind of facades elements or other kind of elements, architectural elements that are relevant. So in this way, you can really like strategically search for things. Yeah. So in this case, again, a tower with balconies. Yeah. So we don't have to specify any style because the network, it's already defining, in a way, the style of the office. Yeah. It's like a QPML data set, and we are just querying through that data set, not data set, sorry, a DPML cloud, and we are just querying through that cloud. And the same happens here. You see, we have a tower with glass facade versus a building with glass facade, a plain overhanging volume, and facade perforations. So one of the problems with this for us was that this is a sort of, you have a network that the DPML network that has its own latent space and it's able to generate designs, and the language model in this case is used only to query, to extract from that latent space. But we also wanted to reverse things, and we wanted to start to look at, can we type in our own text and have a network that we train understand correctly certain prompts that we input. So in this case, we have this example, which are still very blurry. They are not, the network still needs training. But this is something that we are working on currently, trying to reverse also that practice of not only querying, but also trying to have a model that is able to generate based on descriptions. But in this case, the model that we are using is trained with our own data sets, and it's trained with our own description of those data sets. Yeah? Because for us, when we say a cantilevering or aspiring object, there are certain kind of aesthetical features that we are referring to, which if you use a network that was trained somewhere else out there, it's not going to be the same. Yeah? So for example, in diffusion models, the ones that are pre-trained, I believe there are just 4 architects that can be recognized by its style. So if you type in the style of that architect, then the network is going to output something that describes in a way that architect style. So that's a big problem, I'll say, because that means obviously they're not architectural specific networks. And in this case, the same happens also here. So we have our own network trained text with images paired. And like this, in a way, we can describe better our own data sets, our own data sets and what we mean by certain prompts. So just going over again the 3D node. And the last part that I'm going to show is, I also showed this a few months ago to DDES. So this is something that we are currently working on, and I don't know when we are going to be able to show some results here, but this is under construction, let's say, a work in progress. So we started to bring in this idea of federated learning, which allows, in a way, devices to share prediction models collaboratively while keeping all the training data on the local devices. So for us, why that it's important is because we are trying to, in a way, we are trying to figure out a way to bring in our designers' intuitions and our designer preferences into the mix, and have this kind of nice collaboration between the neural network, the Diffusion Model network, and our designers in the office. So Diffusion Model network, again, it's a multi-model or multi-node in a way kind of network. We have multiple types of network that we are working with. Some of them are diffusion models, some of them are GANs, VAs, like variational autoencoders. And for us, it's always in a way important, in a way, which is this relationship between the network and the designer. Which are the rules of the interaction? Where, at what level of design the designer can interact? And the way that this is it's set up, then, because it's a node-based kind of network, designers can choose in a way which network to use at what level and to connect that network with which other network. And they can create in a way this kind of like elaborated way of interacting with the network in a very friendly way. And the same idea also here, like how are networks among themselves being connected, and how are groups, teams of designers interacting with networks and so on. So going back to this kind of idea of federated learning, so that's what we are looking at. We are looking at how exactly we can get perhaps the data generated by user and then use that kind of data set as a way to extract preferences and then bring those preferences into the main network. So initially how this works is that initially the model gets personalized locally based on the usage of data and which is generated by the user. And then from there, all users, imagine you have multiple users doing the same thing, like data is generated, and all users updates or what's happening is like we have the data set that is locally, and then the network is training to, when the computer is not active. So the network starts to train locally, and based on the data sets that are generated by each designer. And once you have the network trained, the weights of the network are taken and are put into or aggregated into one big pool. And within that pool, there's going to be a consensus in a way that's going to be established. And from there, it's going to go back into the main network, which is going to be now trained and influenced by all its kind of personal kind of preferences from designers. And this cycle in a way that repeats all over again. Yeah? So you have users constantly generating the network constantly in a way training, and then those updates start to be brought back to the main network. So we envision this kind of like idea where you have like multiple AI and human agents interacting. And for me, it's always like this idea of how is that interaction going to happen, yeah? Which are going to be the rules of that interaction, what kind of models we are going to have, how we are going to interact with them, you know, which are, at what level are we going to apply in a way those rules of interactions, how we are going to engage, can we have design somehow as a sort of self-organization of AI systems. So this concludes the presentation. Thank you.
Thank you. Thank you, Daniel, for the great presentation. Mainly discuss on creativity, and I think also introduce the process, how you implement the AI methodology in architecture design. So we have a lot of PhD students. In Tongji, we have more than 15 PhD students take these courses. And also we open to some other universities in China to invite more PhD candidates to join this discussion. So I think it's really interesting. Probably mainly I want to put forward some questions firstly to Daniel. Last year, I think extremely special when you introduce your work in Himobro. I think it's kind of new augmented creativity adding to the design office, actually based on the dozens years of practice from Himobro. I think that's extremely interesting to set up the, you name this Latent Space, which actually based on the data database from the office, and actually which create some new possibility. And the special, still we can see special style, and based on, so any working flow will leading to some special style. So we can see this kind of uncertainty and linear space, which produce actually by this methodology. So some question goes to the first. I think some of the candidates here also make research on that, and they're quite interesting. You make the three-dimensional 3D space quite fluent, which actually based on the image, and based on sometimes based on a two-dimensional plan, that's two-dimensional image. So could you mainly introduce this kind of 2D to 3D transformation methodology? Because 2 or 3 candidates asking the question, and from your practice, they want to know more details on that. Probably you can add in some introduction on that first. And secondly, I think it's interesting for this latent space. You name the clip, some clips on it. So actually, we want to understand. So the clips you make option is extremely interesting, but actually that also based on the image, and it's kind of collage or kind of different genetic generative process for all these kind of images. So as an architecture discipline, we still make discussion on the meaning of the image. So you also at the very beginning introduced artificial intelligence, which is actually, it's more like a searching process in the world. Actually, everything already exists, like Costas mentioned. But I think AI is a great way to searching all the infinity possibility for the special genetic relation, which based on maybe one office, maybe one style. So the question goes to still the creativity. is the creativity, as you mentioned in your diagram. It's a lot sometimes about the diffusion is like jumping out of the already exist knowledge. So as a knowledge system is the definition of architecture intelligence exists in this kind of searching creativity. And is that kind of a style which also give the limitation of, because searching or based on the existing knowledge system. So is there any possibility to jumping out of the existing knowledge system? So what's the new creativity to, is that the expert system? Because some of the researchers, some of the experts, they still create maybe some new algorithm, maybe some knowledge which is deeply on the structure or on the environment performance analysis. So they can create some knowledge which is not exist at all. So the question goes to, is it kind of searching in the latent space can really create the new knowledge in the future? So that's the second question. Maybe I would like to start from this basic.
Okay, so I'll start with the first one. So in our case, because we are an office of 50 years, 50 years of practice, we have something like 950 projects, competitions and build projects. So because of that reason, for us, it's quite easy to generate 3D data sets because we have all our buildings, we have them as 3D. So it's quite easy from in that regard to create 3D for us. If we engage in process of from image to 3D, mostly we are engaging in this kind of almost like scanning kind of processes or photogrammetry kind of processes, where you start to stage things together more than actually, because otherwise you cannot, from 2D, you cannot really create a 3D. You need multiple perspectives of an object for it to be able to generate the 3D. So that's how we are engaging there. It's mostly that a lot of things we use certain ideas of representation, like depth maps, for example. It's still an image. It's a depth map, but that depth map can give a certain information to the network that an image by itself is not going to give. So the way that that network with the depth map will learn better than a network that doesn't have the depth map, for example. So in that instance, we have multimodal kind of way of training it, where you can really then extract the depth map and have images, and like that you can really train correctly the network, or much better. That's briefly, like without saying too many things that I cannot say. But that's our advantage there. We have our buildings as 3D. It's easy then to create the 3Ds because we already have them. We just have to clean them and have them nice as homogeneous meshes. And once we have that, we have a data set. On the second question about latent space, so for me, where I love AI to go in architecture is that diagram that I was showing with from Giro with the stone. So you have a block of stone and you're pushing it or dragging it. And if you have just a model that it's interpolating, that mostly is going to come up with exactly the same solution. So you have a block of stone, you need 20 people to drag that block of stone, and like that you can drag it. But if you have networks that are actually able to go beyond that, then they start to propose, okay, you might want to put some wheels, you might want to put some, put it on a river, and like that you can transport it or something. So that's the kind of level that I'm looking at. So when it comes to Diffusion Model, like the Diffusion Model network, so the latent space, yes, we can say that it's a sort of universe which is quite big, but still kind of constrained in the sense of it's the same style, it's the same Diffusion Model. It's not like going outside. But for us, the game there is not necessarily to have the network getting out by itself, but through interaction with humans. Yeah, we are going to interact with the network. We are going to propose new ideas, and that network now will start to learn from those new ideas and start to expand the bounds of that space. Yeah, but not so much at least when I'm talking about latent space. Yeah, not that much as just getting outside. Yeah. Now, if we use other networks, because Diffusion Model network has multiple nodes. Yeah. If we use other networks where you try to imagine in a way like query networks, where you have, let's say, two perspectives of an object, and the network has to create for you the third or the fifth perspective without having that data, then I think that's already a sort of network that allows you to go beyond. Yeah. So I think it depends on which types of networks. Yeah. If we when we talk about latent space, I think we are mostly talking about DC GANs. We are talking about style GANs, this type of networks. Yeah. But there are many other networks that they are not necessarily latent space. Yeah. They don't have latent space. Yeah. They have other ways of operating. Yeah. So in that sense, you can really go outside quite easily.
Good. You mentioned the networks, and also in your lecture talking about the deep networks. That seems a lot of potential interesting research topic in the future. So who can actually set up like a library or its kind of procedural which can actually helping all the designers to engage into this the deep network system. So actually, you introduce a lot of new algorithm or new AI methodology into the architecture discipline. So who will do that work to set up this deep network for all the designers in the future? So do you have any thinking or plan for that, or how to establish a community that can help all the designers how to participate into this society? Or it's like the super global brain in the future, AI brain. So do you think we can have some it's like a fundamental architecture thinking brain for all the designers in the future as a platform? Do you think any possibility of that?
Well, I think could be doable. Could be I think an interesting aspect, because what's happening is like these models, they are very very complex. Sometimes they are very easy to output results that are very appealing, but that doesn't mean in a way that the result is really a correct result, in the sense of like I'm really concerned about this aspect of overfitting and underfitting networks, because we might look at the result and we might think that the result is good, but we don't realize that actually we are in a infinite loop in a way, because that network that I'm using perhaps is just repeating a kind of information that was in the past, and it's just showing it in a way that for me comes across as new, but in the end is the same kind of solution, to the same to a new problem, which it's problematic that, but I think will be good then to have like architects engaging, maybe have like discourse channels where you have architects looking at one type of neural network and figure out all the ins and outs how to use that network, because I think that's going to avoid then these issues. So that's one approach, but I think that approach is very, very expensive, in the sense of I don't think there are so many architects willing to do that. And I'm seeing this in the context of parametric design. So I think with parametric design, we ended up with the same problem. We ended up with some specialized users. And in the end, most of the profession is not really using parametric design. So I think also here with AI might be the same kind of danger. If we push everyone to learn AI, you're going to end up with some specialized users, and that will be all. But I think then a better way would be there has to be a sort of interface that can make it very easy for architects to interact with AI. And certain networks, they start to get there to a level where you don't need any more to train because you have pre-trained networks. But having pre-trained networks comes with a downside because there are strong biases in the pre-trained networks. Like I was mentioning, if you're looking at the big models that are out there right now, like language models, they're not really trained on a sort of language that architects use necessarily to describe architectural problems. Yeah. So then when you use that network and you use the language that you use to describe an architectural problem, you cannot expect the result to be that good, yeah, because that network was not trained with that kind of way, yeah, that kind of language. So yeah, these are two of the options, yeah, that we have. And for me, like my dream is like what I'm trying to do with the Diffusion Model network. I'm trying to have the federated learning as a way to somehow keep designers in the loop and the network in the loop and have it as friendly as possible, you know.
Good. At the very beginning of your lecture, you mentioned the expert system and the learning system. I think that's extremely important as the beginning of this topic. And actually, when I facing and talking to a lot of professors, not in architect discipline, for example, structural engineer, mechanical engineer, they all actually implement artificial intelligence in different scenarios. And I find extremely interesting research from their approaches. Actually, when we talk to each other, we need some fundamental like digital ground or fundamental common ground, how to achieve different collaboration in the future, because architects may be implemented to generate different form, some special spatial possibility, right? But actually, like the structural engineer, they actually just try to achieve some more efficient or the most efficiency structure in a very detailed structure system. So it's like different approaches to have the expert, you mentioned expert system actually is totally extremely cross-discipline. So, so I want to know your understanding how to define different expert system and based on different knowledge system in the future, and how to educate because we have a lot of academic topic, especially in the PhD level. So how do you think we should define our expert system in the future from a researcher's perspective?
So here, just to make it clear, when I'm talking about expert systems, I'm really talking about certain softwares and like, you know, for example, Grasshopper can be considered a sort of expert system because the knowledge is encoded into it, and then you just access the components and you get, in a way, the result based on the expertise of the person who wrote, in a way, the component. Yeah, so the knowledge is there. So that's what I mean by an expert system. And for me, it's like it's not necessarily always a black and white thing. It's in the sense of we still have today, we still have Excel, for example. Yeah. So you might wonder, why do we need Excel? Yeah? But when we have so many other super advanced tools, and I think sometimes that's fine. Yeah? There are certain tools that they are perfect for what they are doing, and you don't need to have an AI for that. Yeah. So in many aspects, when it comes to design, also I think you're going to have perhaps certain things that are going to still be done with parametric design. Yeah. And then other aspects are going to be AI, but you're going to use them with AI. We are going to use AI for those aspects because AI is going to give you the advantage, not because another reason. Yeah. And I think the same thing happens also with more with disciplines that are like engineering, you know, because there you can say, well, there's not that much play and artistic creativity, like in the case of architecture, yeah, where we play with design. Yeah. The entire space there is more rigorous, it's more strict, it's more scientific, and so on. Yeah. So you might wonder like why they're using AI, but in that case, like for example, to explore certain solutions, yeah. So to explore the space of possibilities, like when it comes to structural optimization, for example, AI can help a lot there to really go fast through certain options, or even to come up with completely new ideas of organizing structure. So I think that's where engineers see in a way the potential there. And I think for us, that's also a good thing because we are using finally quite the same tools. Because until now, architects are working with Rhino and Grasshopper. Engineers, they work with other softwares, and there's always this kind of compatibility in a way issue, and you cannot really share that easily information. But if we use probably the same model, the same kind of AI, I think this kind of collaboration will start to become more easier, between architects and engineers, just because we are using the same kind of tools. Yeah.
Okay, Neil, do you have any?
Yeah. Thank you. Thank you, Daniel. It's always good to hear. I think there are a lot of people who like to think they know a lot, but there are very few people who do know a lot, and you're one of the people who really knows a lot. So always appreciate it. Just one comment quick before I ask my question. I don't think that we necessarily are using the same models. I think engineers are using topological optimization. I think this was what Mike Shee's.
No, what I mean is that if you use AI, because topology optimization is not an AI, not at least not in the sense what we understand today through AI. When we refer to AI today, we are referring to neural networks, this type of networks.
Yeah, no, that's what I meant. I mean, the term AI is used generically, and there's a huge difference between the topological optimization and deep learning. But no, I had got a different question. So I wanted to, and this is partly to do, I don't know whether you've been following what's been going on in the last few days, but, it seems like, things are exploding in different areas. I think the DALI 2 collaboration between Patrick and Refik has produced some really astonishing results. But even more recently, in the last few days, literally, we've with Google releasing their conversational AI Lambda, and there's a huge controversy. I don't know if you noticed over the weekend, literally about this. There was a Google engineer called Blake Lemoine, I think his name is, who really is convinced that AI is, or at least that Lambda is sentient. And it's led to this huge, I think he's getting sacked for some reason. He's certainly not given access to Lambda anymore, but it's a huge controversy, and I think that I think it's fairly clear that AI is absolutely not sentient, but it's interesting. It's really interesting that someone should think that or believe that, and that kind of, in a sense, really locates the real difference between human beings and AI. We're people who think or believe. That's not something that AI does. And in many ways, we're meaning-making machines. We're obsessed by this, and you could even argue that religion and so on is all a product of that obsession with meaning, that sort of and beliefs and so on and so on and so on. Anyway, I don't want to get down there, but I want to sort of ask the question. Really, is, in a sense, my main concern right now is the issue of anthropomorphization that seems to be implicit in everything. I gave a paper for Kostas a couple of weeks ago about ADAR, this kind of humanoid robot, and we have Sophia the robot, and God knows what else, and everyone is taken in by these things except in the AI community where they think they're complete bullshit. But I think what is interesting is that the concept of anthropomorphization is that really the problem is, how do we ever step outside of it? And especially in the language that we use, and I know that you flagged up the word creative and said, well, actually, this is not, there are different types of creativity, but it applies to every single aspect of AI where we use human terms, so learning, intelligence, understanding. I think you use the term understanding, if the system understands this. And the really question is how do we ever step outside this, or how do we ever even get close to understanding the other, or the world of AI, in its own terms, and I think that the danger is that there are two sides of the coin right now. One is that we risk the whole, projecting human values onto AI, which is what I've been talking about just now. But there's the opposite one, which is to say the imagining that we are speaking in technological terms about AI when we're only really faking it in a way. So can we only ever see the world in our terms, and will we ever really be able to comprehend that domain? And I think this, in a way, there's a big sort of issue right now. I think we need to understand the anthropomorphization and those processes that are deeply embedded in how we see the world. And yeah, anyway, I just wonder what your thoughts are on that, and whether you've been following that particular debate, which has been raging on the internet in the last few days.
Do you want to open the can of worms?
Well, no, but I think it's, I mean, it's been neatly closed, shall we say, and I think that's a problem in some senses.
Yeah, I mean, for me, it's like I'm willing in a way to hear to hear people out, like what terms will be better to use to describe, and I will be fine. I have no problem in a way to describe it as learning versus not to describe it as learning, because I know that when I'm saying learning, I don't mean human learning, you know. And I think that I mean, please, something that is implicit, yeah. When we are talking about machine being creative, I think no one actually says that a machine is creative like a human is, you know. So in that sense, it's almost like a social understanding that we have, like. You know, everyone that says that, you know, for sure that when you say artificial intelligence, we know, well, artificial, we know that, well, it's a wrong word, perhaps, artificial, but we understand what we mean by that. Yeah, I think, and we should not probably combine Sophia, which is a pure marketing kind of push, versus other kind of discussions that we have about AI. Yeah. Because in that instance, yeah, I understand that it's a marketing push. They're trying to make this kind of story of humanoid, in a way, robot or something. But I don't think no one thinks, or at least myself, when I'm thinking about AI, I'm not thinking about a robot. Yeah, when I'm thinking about like some intelligence, I'm not thinking necessarily about a body. Although I understand also arguments of, you know, intelligence without body. Those kind of discussions are, yeah, important. But I have no problem, to be honest. Like I can.
Well, yeah, I mean, I understand the fact that you're aware of the difference, but you know, the problem is, and Philippe Morel, one of my FIU DDES students, candidates, is working on what is the term we should really be using for AI, in terms of intelligence for AI, because intelligence clearly is problematic in some ways. And I'm kind of thinking of the way that Derrida used to use these terms, where you cross them out, you know, and say.
But for example, we have an AI playing chess, you know, and it's just repeating in a way, or using a sort of brute force, and it's able to beat a human player. Yeah, and we are considering that machine to be stupid. But what's that to say about the human then, if that machine is able to beat a human, yeah? Because we consider a human to be intelligent. So why do we use the word intelligent then for humans, you know? When the machine actually, like, whatever, it's a different process, for sure, it's a different process. But it's
no, I understand that, but how do you flag up the difference? Because, you know, frankly, 90%, 95% of the people in the world think that AI means a robot, and it obviously doesn't, for anyone who knows anything about it. But most people think that, and you know, I think it's almost like we need to really shake people up, and to not to assume that they get it at all, but to somehow highlight, flag the dangers of thinking in this way. Because, you know, I mean, let's face it, Sophia was taken to the Venice Biennale last year. Ada has just been to Venice Biennale for art. Even people, supposedly sophisticated people, are falling for that trap. And that is a real problem, you know, and no one's going to really understand AI while they have such a simplistic understanding of it. That's my concern.
Yeah,
I think I want to adding something to Neil. I think because in Tongji we have another school, design school. They organized a very big event last week, and especially topic on AI in the artistic design part. And we engage and make a lot of discussion. Actually, that is very important. The fundamental question is the future of intelligence. Is the future post-humanism? Is the post-humanism still human-centric? So I think the intelligence augmented design actually should be, so from my perspective, still insist human-centric. It's like expanding the skills of human. It's not replacing the architect or designers. I think that's the fundamental question we need to clear. I think your point actually is the future digital object should be the centric. Is that right?
No, okay, no. First of all, I think that there is no such thing as digital object. I mean, I've read that text and I think it's nonsense. So first of all, there is no such thing as there's no such thing as digital building. That's obvious. That's kind of clear. So that's kind of a mistaken idea. I was actually part of that conference, Philip. So that was what I was referring to when I was talking about ADA. So I think that's, I was referring to all that. So no, the thing is that right now the debate is moving on so rapidly, so quickly, and trying to keep pace with these things. I even wonder whether GANs have got that much of a future because of the way they're operating. But it's more to kind of, I think we almost need to really Sorry, go ahead.
They're going to have. I mean, for me, it's like, for me, I'm never a black and white kind of person, because yes, GANs are outperformed now, let's say at image synthesis by diffusion models, let's say, but okay, still GANs are good at other kind of things, the same way like Excel is still around, and it's not because it doesn't want to die, it's just because there is usage for that kind of software, And also with GANs, I see it like that. I see it as this is just a landscape that we are just starting to develop in terms of tools in architecture and all over. So is that going to be GAN? It's going to be DALI? It's going to be this. The more tools we have, the better, I think, because in that way we can really like look at different problems that we are trying to solve, and we can really like pick from this toolbox that we have, which is the proper tool actually to solve this problem, because otherwise there is a tendency to go with the latest like DALI, Mid-Journey, and so on, and suddenly we make big claims the same way that we make claims about Sophia that is conscious or something and those kind of things, and suddenly we make big claims about Mid-Journey, DALI, and so on. When for me it's like, well, it's just, you'll see it's going to peak and then it's going to disappear. There's going to be another cooler kid on the around the block, and that's going to keep forever like that. But if you have an approach where you say these are tools that might be the perfect tool for this specific problem versus the other tool is going to be the perfect for the other problem, suddenly you start to create a sort of entire library of tools or a toolbox of tools that you can work and operate. Because I mean was my objection from the very beginning when it comes to language models. Like, you cannot describe through text what you describe through an image, for example. That's not to say that there is no room for language models. On the contrary, there's plenty of room for language models, because in the design process, the same person designing, sometimes you have moments where ideas are very vague in your head. And perhaps what you're going to do is you're going to use certain prompts which are vague, and you'll have a language model that is going to give you some ideas. And suddenly those ideas might inspire you, and now you start to take it to a more rigorous process or something else. So for me, I don't see it necessarily like, it's a competition like in that sense. So like DALI is out, perfect. Okay, let's see how can I bring that in, where can I use it, where will be the best place where we can use that. And that's my approach also when it comes to DPM now. I'm not stuck on one model. I'm always looking at, okay, which are all the other models, which are the potential that each model offers, and where I can bring that model into the mix to actually have this entire network perform even better, So that's the way that I'm looking at it.
Can I just add very briefly, well, I was going to finish my sentence, just to Philip, and I'd say I totally agree with you about the kind of this issue about post-humanism. I completely disagree with the notion of post-humanism. That's why I always give Matthias a hard time for using it. And it's actually the comment that Andy Clark makes, against people like Catherine Hales, who talk about the post-human. He said, no, it's precisely the fact that we are human subjects with plastic brains, that we can adapt to these technologies so they become extensions of what it is to be human, a kind of prosthesis, as it were. So I completely agree with you on that, Philip. And the word post-human makes no sense to me at all.
Yeah. So imagine like the world where we can talk. Each individual in the world can talk with the entire history of the world. Just talk, have a chat. I think that's going to expand like our minds a lot, yeah, and we are going to augment in a way humans in that kind of way. So, and also like we are very egocentric in a way as people. I don't think we are going to let it happen that that things are not going to be about us as humans. Yeah, we are going to shape the technology in a way that is going to work together with humans, not separate in a way. You know.
But I just think that, sorry, it's about a final comment. That was the comment that Memo Acton's made, and he's been exploring also DALL-E 2 in a very interesting kind of way. And what he's saying is that when you can draw upon the entire internet, I mean, you are having a conversation, not with all human knowledge, because there's some that before pre-1997 or something that's not out there, but you are having an entire conversation that's all out there, you know, fiction, non-fiction, and whatever else, it's out there, you can have that conversation, which makes it extraordinary, the situation in which we find ourselves right now.
Yeah, definitely. And I think also like for architects, like even if you look at certain aspects that don't have to do necessarily with design, yeah, they are, let's say, history. So you have historical parts, yeah, you have like AIs that are going to help you understand history in a way that, you know, you'll never be able to do it just to go to a class, to a course or something, yeah. And so you're going to have AI that is going to show you exactly like all the ramification, how this developed to that one and so on. And suddenly you're going to have a completely different understanding of things. And I think the same will happen right now. If you look at Midjourney, at diffusion models, and I think also DALL-E, they are trained on certain styles, certain artists. You know, there are certain artists that are more recognized than other artists when you use their name. Yeah, so you can suddenly start to breed between artists and have this kind of plays in a very coherent way. Yeah? So something like that before these networks, you had to spend like how many years? 34 years of your life to reach that level where you're an expert on both painters, let's say, and then you are able somehow to crossbreed them somehow, you know. So I think those things are really amazing. And the only thing that I think is going to change is that things are going to get out of fashion faster than they did before. Yeah. So right now we are talking about DALL-E. Tomorrow probably we are going to talk about the Google image gen, or how it's called, if they give access, yeah. And the day after tomorrow we are going to talk about another one. And you are going to have this kind of creative curve, what we call creative. It's going to last a few months maybe, you know, because that's what's happening right now also with Midjourney. If you just go online and you're bombarded with Midjourney, you know, which is great. I mean, I'm not saying anything bad about Midjourney, but I'm just talking about this aspect. There's going to be an oversaturation of this, and then people are going to lose interest until the next thing is going to come, yeah? And then keep going like that, yeah. So that's why for me, it's like my approach is like not to fall into that hype, and just try to look at the tools as which is the need that they are serving, and where can I use that, yeah.
Great. So any question from the floor and all the students? If you have any question, you're welcome to put up your hand. You can see Mark from RMIT here. Would you like to put forward a question? Okay, I think it's a great time for Daniel help us to generate to start this PhD program. It's a great morning. I think we are still keep eye on Daniel, and looking forward to see the new creative procedure and design methodology you can contribute to the Architect Society. So thanks a lot for your great lecture. I think it's really good starting. And we also want to invite you to contribute the essay in architecture intelligence, which we just launched this month. So looking forward to read your paper and to understand your thinking methodology. I think it's extremely important, as you mentioned, the individual searching methodology and try to find some new approaches. is a creative part for the architects right now and for the research as well. So thanks a lot for your time, and thanks a lot for your contribution. So looking forward to meet you soon. Bye-bye.
Thank you for the invitation. Thank you, everyone.
Okay, bye-bye.